All right, welcome to The Explainer. Today, we are diving deep into a genuine cosmic mystery. And what's so cool about this one is that it doesn't start with some shiny new discovery, but with a really strange clue, one that was found buried in old data. A clue that might just change everything we think we know about black holes. So let's just jump right in with a fascinating question. What if the most silent objects in the entire universe aren't actually so silent? What if black holes, against all odds, leave behind these faint cosmic echoes, tiny ripples in spacetime itself? And this is where the whole puzzle really begins, not with some brand new high-tech telescope, but by scientists going back and looking at old records. They spotted this hidden detail, this tiny little inconsistency that everyone had missed before, and now, well, it's causing a major stir. And that brings us to our first clue in this whole investigation. See, this is one of those critical moments in science, where what we actually see happening out there in the universe just doesn't line up with what our best theories predict should be happening. Now, the key word here is repeating. This isn't just some one-off glitch or a fluke in the data. It's a persistent, repeating anomaly that keeps showing up in these echo observations. And in science, when a strange signal repeats itself, that's when you have to start paying very, very close attention. This right here, this really shows you the core of the problem. On one side, you have our best computer simulations, built on everything we know about physics. And on the other, you have the raw data from our telescopes. The problem? They're telling two completely different stories. Now, you might look at this and think, hey, 98% accuracy, that's fantastic. And you're not wrong. Our models are incredibly powerful. But here's the thing. In physics, almost just isn't good enough. The simulations are nearly perfect, but they consistently fail at these crucial moments, missing the mark by just enough to make scientists wonder if something fundamental is wrong with our understanding. So this nagging little discrepancy has led the scientific community to basically identify two main suspects. Two primary theories that could explain what's really going on out there. Yep, the entire mystery really boils down to two possible explanations. And each one has completely different and pretty massive implications for how we see the cosmos. Okay, suspect number one is simulation failure. And this is a huge idea. It suggests the problem isn't with the data or the telescope, it's with us. The theory is that our fundamental rulebook for the universe, physics itself, might be missing a chapter, that our code is incomplete. Then you have suspect number two, spatial distortion. This theory says, no, our physics is totally correct. The problem, it argues, is that something else is out there in the vastness of space, some kind of unseen structure that's acting like a cosmic funhouse mirror, bending and warping the signal before it ever gets to us. So this really lays out the choice, doesn't it? Is the flaw in our understanding, which means we might need to come up with brand new physics? Or is the flaw in our observation, meaning we need to go on a cosmic hunt for whatever it is that's getting in the way? So with two competing suspects in the lineup, the next question is pretty obvious. How in the world do we get a verdict? How can we possibly solve a mystery on this kind of cosmic scale? Well, the answer lies right here on this timeline. We started in the past with that unexpected discovery in old data. Right now, in the present, we're debating these two big theories. But the real moment of truth, that's in the future. There's an upcoming data release that everyone, and I mean everyone, is calling the real test. And the reason that test is so important is because the stakes are just incredibly high. We're talking about more than one strange signal here. This whole thing challenges the accuracy of all our cosmic models. It gets to the very core of how we understand black holes, and it could, potentially, kick off a whole new era in physics. This quote from the researchers involved really just sums it all up. If this same strange pattern shows up again in the new data, it basically confirms that our current ideas just aren't cutting it. We would literally be forced to go out and find a brand new explanation. And all of this just leaves us with one last, really mind-bending question. This entire mystery was unlocked from data we already had, data that was just sitting there. It really makes you wonder, what other profound cosmic secrets are still out there, just waiting for us, hiding in plain sight?